Happy day. Today we will see quicksort. Sorting is one of the most important operation which will happen in a database. So, we are going to see one method called quicksort by which we can sort a given set of data. Quicksort is one of the method which is being used in all library functions which will be helpful for sorting. So, quicksort belongs to divide and conquer strategy. Divide and conquer strategy is one of the algorithm design method where given a problem, what we are going to do is we are going to split the problem into k subset and we are going to solve all problems in order to get the final solution. Usually whenever you go for divide and conquer, the algorithm will be implementing using recursion. So, in quicksort what we will do is we will try to place one element in its proper place. The one element which is going to be placed into its proper place is going to be called as a pivot element. So, once we place the pivot element in its correct position, the array is split into two parts where if you see the left hand side of the array will have lesser values and the right hand side of the array will have greater values and the pivot element would have occupied its correct position. Once we sort the number there will be a position occupied by that number. So, pivot element would have occupied its correct place. This is the diagrammatic representation of quicksort. Here if you see the given problem is split into three parts. One is the pivot element occupies its proper place and on the left hand side you have a subproblem which has to be solved and the right side you have another subproblem which has to be solved. Now, we will take this example. If you see here, we have been given 9 elements 65, 45, 75, 80, 85, 60, 55, 50, 70. Now, I want to sort the given number. So, what I am going to do is I am going to consider 65 as a pivot element. According to me, my first number is a pivot element. So, to place 65 in its proper place, what I am going to do is I am going to scan the elements starting from left to right, searching for a number which is going to be greater than 65. Actually speaking, we have to search for a number which is going to be greater than or at least equal to 65. So, to do that I need, whenever you access an array you know that you need an index variable. So, to access the array from left to right I am going to use I. Similarly, after I get a number which is going to be greater than 65, I am going to scan the elements starting from right to left to find a number which is going to be less than or equal to 65. For that also I need an index variable. So, I am going to use an index variable called P. So, I is the index variable which is used to scan the array from left to right and P is going to be the index variable which I am going to use in order to scan the array from right to left. Now, if you see I have shown in step 45 is not greater than 65 whereas 75 is greater than 65. So, 75 is a number which is greater than 65. So, I am going to stop my process there. Note down the position of 75 is being placed in third position. So, that is going to be assigned to I. So, I represents the index of the position of 75. Now, I am going to repeat another process. I am going to scan from right to left searching for a number which is going to be less than 65. If I see 70 is not less than 65 whereas 50 is less than 65. So, since I have got a number lesser than 65, I am going to stop there and that position is, what is the position of 50? It is 8. So, P is assigned the value 8. So, I is 3. P is 8. Now, using this value only I will decide which number has to be swapped. So, if you see that on the right hand side I have given the condition whenever I is less than P, you have to swap A of I with A of P. Whenever I is going to be greater than P, you have to swap the element in position P with a pivot element. Once you do that, that means you have placed your pivot element in the correct place and you will stop your process. By this time your array would have been split into three parts. One is the position occupied by the pivot, the left side will have numbers less than pivot and the right side is going to have number greater than pivot. So, if you see here 75 has occupied the third place, 50 has occupied the 8th place. So, I is less than P. So, I am swapping 75 and 50. If you see here 75 has occupied the place of 50, 50 has occupied the place of 75. So, now once again I am going to repeat this process from the place where I have stopped. So, I am going to scan for the next number is going to be 80, right. So, 80 is greater than 65. So, I stop there. So, I is pointing to 80. Now, on the right hand side once again I am going to scan for a number which is going to be less than 65. If you see 55 is going to be less than 65. So, stop there. So, P is pointing to 55, that is it is in the 7th place, 55 is in the 7th place, 80 is in the 4th place. Once again if you see I is less than P, so interchange 80 and 55. So, 85 goes to the place of 55, 55 goes to the place of 80. Once again repeat the same process. If you see here, once again I am going to scan from left to right searching for a number which is going to be greater than 65. If you see here, 85 is greater than 65, and once you have got it, scan for a number which is less than 65. From which side you are going to scan? From right to left. When you do that, you encounter 60 which is going to be less than 65. So, the position of 60 is 6, the position of 85 is 5. So, I is less than P. Whenever I is less than P, you are going to interchange A of I and A of P. So, 60 and 85 is interchanged, and once again we are going to repeat the process. How long I will repeat this process? Whenever I is less than P, I am going to repeat this. When you know that I is going to be greater than P, that is your stopping point. Now, we will proceed in the same way. Now, I am going to scan from left to right searching for a number which is going to be greater than 65. If you see here, 85 is greater than 65. What is the position of 85? It is 6. So, stop there. Once again do the scanning from right to left searching for a number less than 65. If you see here, 60 is less than 65. So, stop there. That is going to be P. Now, P position of 60 is 5. So, P will hold 5. Position of 85 is 6. I will hold 6. If you see here, I is not less than P, I is going to be greater than P. So, you have to swap the pivot element with the element at position P. So, here 60 and 65 will be swapped with each other. After that, if you see, 65 has occupied its correct place, which is the 5th position, right. So, if you sort your number, definitely 65 will occupy its 5th position. And if you note here, wow, if you see all elements on the left side of 65 is lesser than 65 and all elements on the right side are going to be greater than 65. If this is so, it means that you have done the procedure properly. Now, the same process, no, I told you this is divide and conquer. So, your problem is divided into two sub-problem, one on the left hand side and one on the right hand side. And I have, see why I have placed an infinity in the last places. See, once you scan from left to right, suppose all elements are going to be greater than 65, then you will not have a stopping point. So, always before you start your quicksort procedure, you have to place a greatest number in the last position. Suppose you are working with 2-digit number, means place a 3-digit number in the last place. Suppose you are working with 3-digit number, means place a 4-digit number in the last place. That is why infinity has been placed in the last place, right. Why? Because when I scan from left to right, I am searching for a number which is going to be greater than 65. Suppose all are less, I will not have a stopping point, right. Now, our problem is divided into two sub-problem. If you see here, what are all the elements on the left side? 60, 45, 50, 55, that has to be sorted. Once again, I need an upper bound, right. I told you we have added infinity. Similarly, here also I need an upper bound. So, your 65 now, which has occupied its correct place, will serve as an upper bound. Now, to sort this element, I am going to consider 60, 45, 50, 55 and 65 will serve as an upper bound. I am going to repeat this process. Similarly, if you take your right hand side problem, what and all you have? 85, 80, 75, 70 and plus infinity. So, this will be the right side problem. So, you will apply the same process on this problem. So, now you have two set of problems to be solved. You will apply the same process. So, if you see your next slide, I have shown how the problem is split. So, 65 is pivot, left side is subproblem 1, right side is subproblem 2. For the left side subproblem, I need a greatest number. So, I am going to use a pivot as the greatest number and I am going to repeat this process. If you see the slide, that repetition has been shown. Now, if this is my subproblem, which is the first element 60. So, that will be considered as pivot, and if you see here 60 has been placed into its proper place. And once again your array, your problem is divided into two sub-problem. Left hand side you have 3 elements, right hand side you have 1 element. So, 1 element means it is already sorted. So, you will be carrying out your process once again on 55, 45, 50. You are supposed to sort that. There you will be using 60 as the upper bound. So, that only has been shown here diagrammatically. 60 is pivot, left side sub-problem is there, right side sub-problem is there. You are going to solve the left side sub-problem. So, the same thing whatever has been said has been shown here. So, sorting the process is repeated until 55 has occupied its correct place. On the right hand side, if you see we have taken 50, 45, 55 and we are sorting it. Once again 50 has occupied its correct place. The problem is divided into two sub-problem. Both sides have only one element, so it is sorted. Now, this is left side, right? Right side sub-problem we had 85, 80, 75, 70 plus infinity. For that also I am going to repeat the same process. In this case, which is my first element? 85. So, I will consider 85 as a pivot and I will try to place 85 in its proper place. If you see in the last line, 85 has occupied its correct place, and on the left hand side you have 3 elements 70, 80, 85. So, you are going to continue the same process with that, but I need an upper bound now. So, I have considered 85 also there. Now, if you see here 70 has occupied its correct place, already 70 is in its proper place. So, 70 will swap with itself. So, in the next slide, if you see here you have 85, 75 and 80. Now, 80 is my pivot, I will try to place 80 in its proper place. Once 80 occupies its proper place, once again left hand side problem has one element, right hand side problem has one element. Now, if you write all the element, every element has been sorted and it would have been placed in its own place. So, this is quicksort. Here we are using recursion in order to sort it. So, I will show you the procedure. So, if you see here, whatever we have done, we checked what was the first condition we checked, always the lower bound must be lesser than the upper bound. So, according to this algorithm, P is the lower bound, Q is the upper bound. So, whenever and I am adding one extra element as the upper bound. So, J is incremented as J takes the value Q plus 1. So, in the last place, 10th place I am placing an infinity, right. Afterwards, I told you know we did a swapping, we scan from left to right, that is called your partition algorithm. In the partition algorithm only we do that procedure. And once we does that partition, the pivot element has been placed in its proper place. Our problem is divided into two subparts, right. So, P is the position occupied by the pivot element. So, what will be the size of the left side problem? Lower bound is going to be P. So, upper bound will be J minus 1. That P, position P we are assigning to a variable called J, and J minus 1 will be one sub problem. J plus 1 to Q will be another sub problem. So, P is the lower bound, Q is the upper bound. The position P know that we have assigned to J. So, J minus 1 will be for the first sub problem and J plus 1 will be the lower bound for the second sub problem. So, here that scanning, that partitioning no, that process is given in the algorithm called partition. So, I will go on incrementing I until I encounter a number which is greater than pivot. Similarly, from right side I will proceed towards left, decrementing the variable P. So, once I get a greatest number and a smaller number, I am going to check whether I is less than P. When I is less than P, we are interchanging A of I and A of P. Suppose I get a ulta condition, that is if I is going to be greater than P, what we have to do? We have to swap the element in the position P with a pivot element. So, that procedure is given, and this small procedure to interchange. How do you swap two values? By using a temporary variable. That code has been given in this, right. And if you see here, always we have to analyze the algorithm, right. What is the time complexity, how much time it takes to execute. If you see here, best case for quicksort is big O of n log n, worst case is big O of n squared, and average case is big O of n log n. And a Python implementation has been given here, the same quicksort I have implemented in Python, and the output is also shown here. Thank you.